Hello, and welcome to another math exploration. Today's topics are, number 7, recognize the three forms of writing a quadratic function and what each one tells us. And number 8, find and explain the special parts of a parabola on a graph. We're going to do number 8 first, and as for number 7, we're only going to do vertex form. Okay, here we go. This is a note that you should have received in Google Classroom. If you didn't, you can always make one by yourself. I want to talk about the parts of a parabola. Right here, these arrows are pointing at where the parabola crosses the x-axis. This is our x-axis. Here's our y-axis, just in case it's not visible. These 2 points have 4 different names. One is the x-intercept. Another one, it's called the zeros, because that's when the y value is 0. It's also called the solution. They're the solutions to the equation, and they're also known as the roots. These 4 words are used to say the same thing, but in different situations. Over here, this part, what we're talking about is this dot. This dot is known as the vertex. Just like in an absolute value function, the point where the curve in this situation changes directions from going down to going up is your vertex. It is also where you're going to find the maximum or the minimum point. In this situation, it's the minimum. This part over here, they're pointing to this dotted line. This is known as the line of symmetry, or also known as the axis of symmetry. Because the right side of this graph up to here looks just like the left side. They are symmetrical. They look the same on both sides of that line. Okay, the last point we have is right here. This is a point you should be familiar with. It is the y-intercept. Make sure you have this information in your notes. I'm not going to worry about this one for now. Okay, now we're going to talk about some of the words. The word parabola. This is the U shape graph for a quadratic. And basically a quadratic is y equals ax squared plus bx plus c. That's standard form. Today we're going to learn about vertex form, which is a different one, but don't worry. As long as you have this square in it and no higher power, you are dealing with a quadratic, and its shape will be a parabola. The zeros, where the parabola hits the x-axis. That'd be right here and right there. The next one, the y-intercept. The y-intercept is where the parabola hits the y-axis. That point right there. The vertex is where you're going to find the maximum or minimum point on the parabola. It can be max or min. That's where you're going to find your vertex. As for domain, well, these are all the x values that work in the function. Basically, how far left and how far right does this graph go? So if you look up here at the original, how far right does this go? It does not stop here. It keeps going up, 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 up. It goes up forever, but it also goes to the right forever. And it goes up forever on this side too, which means it goes to the left forever. So the domain for any quadratic, the function, should be all real numbers. The difference comes when we hit the range. What values of y work in the function? So if we look at this one, if this graph goes up forever and ever and ever, the y values keep going up and up and up. But do they come down forever? No, they come down to here and they stop and then they go back up again. So in this situation, the range is everything above my pen. This is your range, not down here. So I'm going to look at this and go -1, -2, -3, -4, 5, 6, 7. All the y values greater than or equal to -7. So the range is going to be y is greater than or equal to, let's look at this one here. Is it going to be greater than or equal to the max or the minimum? Since I'm going greater than, I want all the ones above whatever I'm going to talk about, so it'll be the minimum. If I'm going the other way, I will have less than y, all the y values less than or equal to the maximum. Okay, those are many of the main parts of the parabola. We're going to now look at vertex form. You should have this foldable in your notes. It talks about standard form on the front page. We'll do this on another lecture. Factored form, that's also another lecture, how we can go between the two of them. We're going to look at vertex form. I'm going to zoom in a little bit. Okay, so vertex form. This is the standard, this is your equation for vertex form. Y equals a, parentheses, x minus h squared plus k. What does this tell us? Well, a tells us if it's up or down. A also tells us if it's wide or narrow. Okay. So this number, whatever number is right here, if it's a 1, positive 1, it's up, and it's going to be or neither. Wide, narrow, or neither. The h and k are the vertex. That's why it's called vertex form. So in this one, it tells you, as soon as you look at the numbers, you know where the vertex is, and you know if it's up or down, and you know if it's wide or narrow. Those are 3 things you can tell instantly just by looking at it. For example, I wrote this one down here, and that's an 8. y equals negative 2, parentheses, x minus 4 squared plus 8. What do we know about this? Well, a is negative. Its face is down. Okay, the parabola faces down. A is greater than, the absolute value of A is greater than 2, or greater than 1. Therefore, it's going to be narrow, or narrower than your standard parent function. So negative 2, absolute value of that is 2, bigger than 1. So if this is a positive 2, it'd also be narrower. A 10 is narrower. A negative 10 is narrower. But a 1/2, nope, that would now be wider. And h equals 4, k equals 8. So the vertex, I know the vertex is 4, 8. These are the 3 things I know just by looking at it. That's what I want you to be able to do today. That was our goal. You're going to have some assignments to practice doing this and also naming the various parts of a parabola. We'll do this on a different lecture, finding the zeros, changing it into factored form. Oh, one more thing you do know. Let's go back up to your notes. The line of symmetry. Equals h. So the line of symmetry put it down here. Line of symmetry x equals 4. That means on my graph, if I look at this, here's my graph. 1, 2, 3, 4. There's my line of symmetry. The vertex is going to be at 4, 8. Up here somewhere, it faces down. And it's narrow. I already know this. 4, 8. I don't know if this hits here or on the outside, on the other side of the y-axis. I have to figure that out later. But I know it has this general shape. It's facing down, it's narrow, and it goes through this point. Okay, that's all we need for today.